All right, these are your video notes for section 5.10. We're going to start with a little recap review first. There's a lot of stuff that kind of gets recycled in this set of notes from previous sets of notes, so we're going to sort of build up to that and look at all the different things we can do with factoring, solving, and graphing. So let's start with a little bit of factoring review. Getting started on this problem, one of the things I think about with solving by factoring is when I have numbers like 2, 8, and 10, that 2 can be taken out as kind of a getting started factoring. There's another thing I might want to think about, and that's dividing it out. So there's a difference between I take it out front, like I pull 2 out of each spot, but I leave the 2 there, or I just divide everything through by 2, which I can do because 0 divided by 2 is still 0. Now as you watch what happens here, so I keep going, and I factor that. Pretty easy factoring. 5 and a 1 are going to give you your 4 middle term. Same factors over here, but you notice I got the 2 coming with and I don't have the 2 coming with. Now the reason I like doing this and not bringing the 2 with is because of what I'm trying to do, which is solving. And when I go to solve my factors, I'm going to get set of each equal to 0 and solve. And the thing is, with this number 2 sitting out there, I could be tempted to bring that with as a solution, like x equals 2, and write it down here. But it's not, because it's not attached to x. The way I've got it over here, at least it's not in the picture, right? So I won't accidentally write it down. So I think that's a good way to go. But it's up to you. If you are okay with the 2 out front and you don't accidentally write it as a solution, you're still going to be fine. For the second one, we're trying to identify a pattern. So hopefully you guys are able to recognize that now. But the way I do recognize it is it's 2 terms. There's no middle term, no bx term. I've got a perfect square number or separated by subtraction. So all those things kind of drive me to that. And then I start thinking about the question of, well, what are the things I'm going to use in the pattern? So I ask myself a simple question. What would I square to get x squared? What would I square to get 81? And the answer to that would be x and 9. When I do that, just in my head, I'm just trying to figure out what I want to call the a and the b so that I can plug them into the pattern and solve. Also, we go to our other methods, which are complete the square for solving or using the quadratic formula. You still want to ask yourself the question of, does it factor, right? Because if you can factor, do it. That's quicker, easier. Complete the square, is fine, but it's a little more work, a little more process. And so I quickly run my factors, right? I check my factors at 9, and I do my inside, outside. I can see 9 and 1, not going to give me that middle term, -4. 3 and 3, also not going to give me that middle term. So then I'm on to complete the square. So remember the process here is to take that number term, constant we call that, slide off to the side, give yourself some space. In that space, we're going to go half of the middle term squared. And then counterbalance, right? So we just put 4 in, we added 4, we got to subtract 4, that's called the counterbalance. Then the 3 terms in blue become 2 identical factors. In other words, if I asked you just to factor this as a standalone problem, here we go. There's be the factors for it. But we rewrite it as a single factor squared. Now, complete the square at this point is done. It's the rest of it, it's solving. So we're going to finish off with the solving idea. So start trying to get the squared part of the parentheses alone. So move that 13 to the other side. Now, because we have a squared and we want to get rid of it, we pull on our square root both sides. Remember, in the process of solving, when you take that square root on both sides, that creates a plus and minus situation. And the last little bit is to add 2 to the other side. And then you could go to your calculator, like in other sets of notes, I had the decimals there. We could do that. I'm not going to do that here, but 2 plus are at 13, 2 minus are at 13 on my calculator would give me my 2 different solutions. Okay, let's do quadratic formula and then solving a radical, and then we'll move on to the 510 material. So again, the first thing I would want to check is, does it factor? Because if it does, great. I'm not going to do extra work like quadratic formula to complete the square. But it doesn't. The factors of 8 in no combination are going to give me my middle terms. So 8 and 1, not going to produce a 4. 4 and 2, not going to produce a 4. So then it's time to... Actually, before we do that, I'm going to check one thing here quick as a little sidestep, the discriminant, right? So before we do the quadratic formula, this is just something else you guys were asked to do, but it's good to figure out what kind of solutions you can expect. And the fact that this is a negative discriminant, this is the b squared minus 4ac, which sits under the root, tells me I'm going to get 2 complex zeros or 2 complex solutions. Now, of course, we're going to go ahead and plug it in and see how it all plays out. So here's our quadratic formula. Drop our numbers in. Remember, those are the constants, the coefficients, I should say, the numbers out front. So we're going to pull those in. Then it's cleanup time. You see that -16 showing up, so I already know that's producing complex or I in my answer. So the square root of -16 is going to give us a plus and minus 4i. So square root of 16 is 4, square root of -1 is I. And then you can divide both those by 2, and you got it. So, all those things are just things to think about. Factoring as a, do I need to do it? Can it be done, I should say. And then discriminant is up to you. You don't have to check that, but it just kind of gives you a heads up, like, hey, here's what I expect. All right, let's see what's next. So solving our root equation, the idea would be to get rid of the root, and kind of the opposite of what we were talking about a second ago, where if I want to get rid of something that's squared, like complete the square, I take the square root. If I want to get rid of the square root, on the other hand, well, then I square both sides. So opposite operations. Now we just start working through our process. So gets rid of your root, good. That's x squared. I'm going to get this stuff combined as just all on one side so I can do the solving. Now again, I would check for factoring. just to see if it would factor. Turns out, pop up some stuff here that it does. Here's my list. I'm looking for the pair that would give me a -3, or at least give me 3 anyway. And I can see that's going to be 3 and 6, so not those two, but I can definitely get it out of there. And then I just get my signs right. So if this term is negative, then I want my -6, which is going to give me -6 on the outside, +3 on the inside. Got it. And then set your factors equal to 0 and solve. Now remember, root equations have one other unique thing is you got to check your solutions. So they got to be plugged back into the original equation to see if they work. And so here's plugging back in, so you can see I plugged -3 and -3 in for my 2 spots where I had x, and then 6 and 6. And then kind of go through the work and just sort of see what's going on. That one checks out. This one I could have figured out kind of right away. That was no back here, because remember, you can't take the root of anything and get a negative answer. So I already knew it was no solution right here, but here also that should prove that to you. Okay, that's kind of our recap review. We're just going to sort of roll on with the rest of the notes and how it all ties into stuff from the chapter. So you can see, even though we're in section 5.10, here we go. We're looking at a set of factors. We're going to do some graphing. Remember our factored form, and then we call those roots as our solutions. And then also we can turn our roots or our solutions into x-intercepts for the purpose of graphing. And then the way we solve is called the zero-product property. I haven't used that term with you guys a whole lot, but that's what I just did a minute ago. You set your factors individually equal to 0, and you solve. So being it's already factored, that's all I really got to do to start. Now, reminder that 2 out front is not a solution, right? We talked about that a minute ago. And then these can instantly become x-intercepts by making that x comma 0. So we got our x-intercepts and our x-intercepts. And then for graphing purposes, I'm going to pop up the whole thing and just kind of talk you guys through it one at a time. So the red, there's my x-intercepts. And then I want to check how far apart they are. I put in the axis symmetry to help us out with that. So it's 4 on either side. That means the vertex sits on that line. There's a couple ways to do it. You could figure out, sorry, it's 3 on either side. That's not 4. There's 1, 2, 3. If there's 3 to the x-intercept and 3 to this intercept, 3 means I would use all 3 numbers in the pattern change to get there in this instance. So 1, 3, 5 would be a total of 9. So I know that my vertex sits 9 below this visual line right here. That's 9. Plot that, then 1, 3, 5, pattern change. You could also do it as take the x value, which I'll show you that later. Take the x value of the vertex, which I know is at -1, and just plug it back in. Quick, put a -1 in there, -1 in there, and calculate it. That would give the vertex also. All right, let's pop up our others here, and we'll probably move on. I don't think I'm going to explain every single graph to you guys, but again, thinking where my intercepts are, 0 and 4, halfway between, that's 2 and 2. So if it's 2 to the intercept, it's the first 2 numbers in the pattern change. 1 and 3, which is a total of 4, puts me down here. Or take your x value right here, which is 2, and plug a 2 in right here, and calculate the y value. That's always an option. And then again, my intercepts here, and then they are 2 and 2. Now, because they're 2 and 2, I'd say, well, it must be 4, right? But actually, look where it sits. It's way down here. That's because that 2 out front tells me it's a 2, 6, 10. So the first 2 numbers in a 2, 6, 10 is a total of 8. So that's why this sits down here, 8 below. Or, again, just throw in the visual axis symmetry that cuts that graph in half and say, what's its x value? It's at 1. Plug in a 1, plug in a 1, calculate the y value. So those are always your options there. Okay, but again, tying the idea of factored form, solve, solutions or zeros or roots, x-intercepts, draw a graph, right? Okay. Now, here's a bunch of practice factoring, so we're going to run through this kind of quick. Progress, I think, from sort of not so many choices to more choices, but 6 has very few choices, 1 and 6, 2 and 3. And that's a matter of me grabbing the ones that would give me my middle term. So +3, -2, +1 middle term. You guys should be getting good at this, where you can just in your head do these real quick, and you look at the numbers, you scan through and go, yeah, it's got to be this pair because 3 and 6 in combination would give me 9, where the other pairs would not, right? Same thing, check your list. Facts of 20, which pair is going to give me a 12? That's got to be a 2 and a 10. Just get your signs right. That's the biggest thing. Get your signs right. If this is -12, they got to be -2, -10. Again, list out 48. Now, a lot in the list, but, look at the middle number. It's 8. So if I go on that list, where is my 8 coming from? It's got to be that pair. And then getting your signs right. This one's a little bit different because, there's no third term out there. So this one actually, a lot of people mess up on. It's simpler than you think. You just take the x out of each term, and you're done. It's factored. So you don't have to do this idea of checking pairs. Okay. Let's keep rolling. The other kind of thing we're going to do with you guys is a factor cancel. So this is really just another factoring problem. And what you do is you start out by getting everything factored. So I'm going to pop those up kind of quick. And what you're looking for, top to bottom, is there anything that's identical? And anything that's identical can be canceled off. It's like saying x minus 2 divided by x minus 2 is a 1. So essentially that becomes a 1. Now, without me walking you guys through all the factoring, but you guys should be able to kind of quickly, like 14, 7 and 2 gives me 5. 16, 8 and 2 gives me 6. 4, 2 and 2 gives me 4, and so on down the line. Anyway, you get those all factored out, so it's a bunch of factoring practice. And then you cancel. So you cancel top to bottom. Whatever's left is just going to be your final answer. Okay, pretty easy, really just a big factoring question. And the last thing for us to do is kind of tie it all back into graphing one more time, and then we'll wrap it up here. So, again, I want to start out by saying, does it factor, which great it does, which means I don't have to do that other stuff, complete the square, that kind of thing. And then turn that into my x-intercepts, so translate those to solutions. Now, I didn't do the solving, I just kind of did it in my head, left that little step out, but x minus 1 becomes positive 1, and x plus 4 becomes negative 4. There's my intercepts. Now, again, trying to figure out where's my vertex at. Well, here's a little bit of a twist on this one. Because if they're an odd number apart, from 1 to 4 is actually 5. What I do know then is that x symmetry has to sit halfway. So I'll show you what's going on over here in a sec, but I just dropped it in at visually what is the halfway point between these two. Well, if they're 5 apart, that's 2.5, and that's 2.5. That puts it at negative 1.5. This is where pattern change is going to help you a whole lot with trying to get the actual decimal, because it's a calculation. It'd be hard to figure out exactly where that's hitting. But what you can do is you just drop it in. Drop it into your equation like your original, well, your factored form will be a lot easier actually. So drop it into your factored form. So I'm plugging in 1.5 for x, negative 1.5. And then I'm just going to run some calculations. So I'm going to do the calculations there, the calculation there. What I just figured out is this x value, which is the x value of my vertex, has this y value. So now I've got x and y for my vertex. And when I have that, then I can go ahead and drop those numbers into vertex form. I got my final equation. Now, if you want to try to run the pattern change, you can, but it'd be, like I said, it wouldn't have been that helpful to get the actual vertex coordinate. You're probably going to have to run through like this. But if you want to see what it looks like, I can run it. So 1, 3, 5. So over 1 up 1, over 1 up 3, over 1 up 5 is up in here. So I'm not actually hitting these on the pattern change. And that's something to remember. You don't always hit the intercepts by running the pattern change. It's nice when you do, and it probably helps the graph make a little more sense. But that's all you got to do for that. Okay, so 510 I said is really that kind of big sort of recap, pull everything back in from the rest of the chapter, and that's it.